Welcome to this explainer. Look, if you're building AI systems, you already know the goal is to make them robust and autonomous. Today, we're tackling one of the absolute biggest headaches in the field, AI hallucinations. We're going to solve this using Google's Agent Development Kit, the ADK, by building a multi-agent system equipped with final verification. Seriously, get ready, because we are going to build an orchestrator agent that uses subagents to browse the web and literally ruthlessly verify its own results.
All right, here's our game plan for today. We'll start with the AI hallucination problem, move into multi-agent systems, build our URL verifier, set up the orchestrator agent, and finally look at execution and final verification.
So let's jump right into part one, the AI hallucination problem, or honestly, what I like to call the danger of dead links. Okay, imagine you ask a standard AI agent a really straightforward question, something like, hey, when does the next Top Chef episode air and what's happened so far? The agent processes it, writes up this beautifully formatted summary, and confidently gives you a list of source URLs. But then you click them and bam, 404 error, page not found. So why does this happen? Why do these agents confidently hallucinate dead links? Well, remember, LLMs are trained on massive data sets, but that data has a strict cutoff. They just don't know up-to-the-minute info. So when you press a single agent for a real-time URL, it often just kind of guesses what a URL should look like instead of finding one that actually exists in the real world. And this brilliantly illustrates the exact limitation we're trying to fix. You can see the stark contrast here. A single, monolithic agent is trying to do all the heavy lifting in one go, which makes it super prone to guessing and giving you those frustrating 404 links. But a multi-agent system, that's a team. It's capable of self-correction, task delegation, and strict verification. Switching to a multi-agent approach completely changes the game for complex tasks.
Moving on to section 2. Enter multi-agent systems, the manager and the employees.
Inside Google's ADK framework, we actually use a really specific pattern to build these systems. Let's define the manager of our team, which we call the orchestrator. An orchestrator is simply an agent acting as a manager that uses other specialized sub-agents as its tools to complete a complex task. Just think about that for a second. We aren't just giving an AI a calculator or a, weather API. We are giving an AI other AI agents to use as tools. It's an absolute superpower for handling complex logic and keeping the system from drifting off course.
Let's get into section 3, building the URL verifier, the strict judge.
Now, what's really interesting here is how tightly we lock down this agent's behavior. We're building a URL verifier agent based on the LLM as a judge concept. So we don't want this agent writing code or having a friendly chat with you. We instruct it strictly to read a web page and return only one of 3 exact statuses: verified, not verified, or inconclusive. By constraining the model to just these specific parameters, it acts purely as a strict evaluator. No fluff. But how does it actually know if a link is verified? Well, here's the secret sauce. The URL verifier gets a specific tool called fetch_URL. It takes the link it's given, goes out to the live web, and actually reads the text on that page. It doesn't guess, it looks at the real HTML. If the page 404s or if the text is totally unrelated to our topic, the judge strikes it down. This is what completely prevents embarrassing fake news or dead links from sneaking through to the user. On to section 4, the orchestrator agent, delegating the work. So we're going to create our orchestrator and we'll call it the researcher agent. Look at its tool belt here. Instead of normal, basic tools, we equipped this orchestrator with 2 specialized subagents. First, a search agent, whose literally only job is to scour Google for relevant links. And second, the URL verifier agent we just built, whose only job is to evaluate those links. The researcher agent just sits back and manages the whole process, smoothly passing the baton between its 2 specialized employees. I really want to highlight this exact quote from the ADK source material because it's a massive paradigm shift. Quote, "Equipping agents not just with tools that are deterministic functions, but equipping agents with other agents as tools." What's incredibly cool about this modular approach is how it lets you manage cost and performance. Since these are separate agents, they can run on totally different models. You could route the simple search agent to a cheaper, lightning-fast model and save your expensive, heavy-duty reasoning model for the orchestrator or the URL verifier. You get total control over the architecture. Let's wrap up with section 5, execution and final verification, the payoff. Let's look at this dynamic execution loop visually. Step 1, you ask the orchestrator that complex question about Top Chef. Step 2, The orchestrator goes, okay, I need links, and calls the search agent, which hands back a list of URLs. Step 3, and this is key, before returning anything to you, the orchestrator dynamically passes those URLs directly to the verifier agent. The verifier uses fetch URL, reads the text, and returns its strict status. Finally, step 4, any link marked not verified or inconclusive gets thrown in the trash. Only the fully verified links are used to generate the final, accurate output that actually reaches you.
The absolute most crucial point to take away from this is that this architecture prevents hallucinated or dead links from reaching your final output. This isn't just about getting some cool demo to work in your terminal. This is literally the difference between a flimsy prototype that falls apart during edge case testing and a robust, production-ready application that users can actually trust for real business workflows. I want to leave you with a thought to kind of spark your curiosity. If we can use this LLM as a judge pattern to strictly verify a URL, what else could your multi-agent system learn to judge, right? Like, could an agent verify code syntax before executing it, or maybe verify a brand's voice before publishing a blog post? By mastering this pattern in Google's ADK, the possibilities for building self-correcting AI are truly wide open. Thanks so much for joining me in this explainer. Now get out there and start building.